Hi everyone, once again we're going to be looking at another topic, and the topic is set and Venn diagram notation. Set and Venn diagram notation. Now under this we will look at the definitions of set and some calculations under Venn diagram, and we have an interactive content here which we serve as a guide. Now what is a set? A set is a well-defined group of objects or symbol. A set is a well-defined group of objects or symbols. So whenever you have a well-arranged object, things or symbol, then we can actually refer to such as a set. Now every element, every object or symbol in a set can be called an element or a member of a set. If element E belongs to set X, it is represented as what we have here, which means that E is actually a member of set X. Now we have an example of set here. Look at the picture we have here. This is a multiple of what? 5 from 1 to 25. So if you look at it, multiple of 5 from 1 to 25, 5, 15 and 25. Then we have 10 and 20. These are the multiple of 5 from 1 to 25. Now look at the what we have here. It's just that we are having multiples of even number from 1 to 25. What are even numbers? Even numbers are numbers that can be multiplied by, that can be divided by 2. So look at this. This can be divided by 2, 12, 22, 14. So all the numbers that we have in this circle are even numbers. And if you look at this, there is an intersection between them. We call this intersection. What is actually common in the two given sets? So 10 and 12, they are actually both even numbers, and they are multiples of 5 from 1 to 25. So this is an example of how a set is being arranged. And this leads us to another example. If you look at this, we call this structure a universal set. I will look at that in the next slide. Look at this. We have 2, 4, 6, 8, 10. So this comprises of what? We can study this comprises of 1 from counting numbers, natural numbers from 1 through 10. Now we have some sub definitions on that set that we need to know. First and foremost, we have subset. If all elements of one set X are also elements of another set Y, then X is said to be a subset of Y. What does this mean? If you can find X in Y, then we say that X is actually a subset of Y. If I can find all the objects in X also in the set of Y, then X is a subset of Y. Now if we are talking about empty set means that it doesn't have any element or member, and we can denote that as this is a example of empty set. This is another denotation for empty set. Now when you're talking about universal set, it comprises of, and we need to work it, is what we call universal set. Now that is if you are given any specific problem or problem to solve. Now we have what we call complement of a set. Now if you can find an element or a subset from the universal set, then we say that that type of set is actually a complement of the universal set. So if you can find some set of numbers or objects in a very big component of a set, then we say that such is actually a complement of a universal set. We are going to be looking at an activities very soon, which will explain this better. Now we have an exercise for us here. Dash is a well-defined group of objects or symbol. I believe that should be what? Set. Set is a well-defined object or symbol. So we are good. Now the object or symbol of a set are called what? What is it called? I believe that should be element or members. Element of members. Let's check. Wow, that's good. We are good. Now that's let's check. Okay, and that's all. Let's look at the next slide that we have here. This is how Venn diagrams look like. It's always is a a diagram that is actually represented in picture. Now let's look at what we have. Venn diagrams are the principal way of showing sets. diagrammatically. So if you are trying to show pictures, you are trying to represent figures, objects, or thing and in a pictorial way, then we can say that that is actually an example of how Venn diagrams look like. The method consists principally of entering elements of a set into a circle or a circles. Like we have example here, you see that this is two circles, so we call these circles. Now we have an example. This is a set, and this is another set. So we can call this set P, and we call this set Q. So this set P, it comprises of what? 3, 6, 9, 12, 15, and 18. If you look at this, I believe these are values that are multiples of what? Multiples of 3. And Q is an example of a multiple of 2, because look at it, 3 can multiply this, 3 can go in this, and 2 can go in set Q. So we can actually show it in this form. Now let's study this. This one we have, if you look at it, there is something that is common to the two of them, which is 6 and 12. So this we call it intersection. So we can call P intersection Q as what? 6 and 12, because 6 is actually common to P and Q, and as well 12 is common to P and Q. Now let's go to the next slide that we have here. This is union of a set. Now why are you talking about union? That implies that you are having two sets and you are bringing the two sets together to form another set. It is actually, we use symbol U to denote that. Now let's look at the example that we have here. This is a set S. It comprises of 1, 3, 6, 7 and 14. While set Y comprises of 3, 9, 13, 14 and 18. So if we want to bring this together, we can now say that we have X union Y. X union Y. So by the time we are writing X union Y, that can serve as another set. You can name it as set, either set Z or set A and the like. So then we are bringing the two sets together, X and Y together. So we are bringing them together. That's all the members or elements in X and elements in Y are being put together to form a new set. So we have this as 1. You can see 3, we have 6, we have 9, we have 13, we have 14, we have 18. So we are actually following the ordering of numbers. So this is an example of how a union set looks like. Now let's look at an activity there. We just quickly look at this. We study this together. This is X, this is Y, this is W, we have Z here. Now for this one, Y is actually a subset of W, because Y can be found in W. Z is actually a subset of X, because Z can be found in X. Now the intersection of W and X is what? 6, 2, 9, 7. That's the intersection. The intersection of W and Z is what? 2 and 9. That's the intersection between W and Z and W and Z rather. Now, if you look at this, W, X, Z, and Y. By the time you are bringing all the sets together, we can call it a union of sets, and that is more or less like a universal set. That is, it comprises of all the objects inside all these sets: set W, set X, set Y, set Z. So all these elements you find there can be in form of a union of a set or universal set. If you are bringing it as union, it's going to be W union X, union Y, union Z. So you are bringing all the elements that we find here together. Now with that, let's look at a past question. Here is a problem involving Venn diagram. We are going to be solving this together. Let's read the question. In a class of 31 students, some study physics and some study chemistry. 15 if 22 study physics, 20 study chemistry, and 5 study neither. Calculate the number of students who took both subjects. So we don't actually know the number of students that took both subjects. We are looking for that. So we are representing that with what? With X. Now, remember that they said 22 actually studies physics, but out of that 22, there are still some numbers of people that study both subjects. So we need to know that the same thing applies to chemistry and Even out of 31 students inside the class, 5 students did not even study any subject. So for us to get the total number of people that are actually inside the class, we need to subtract 5 from 31. So by so doing, then we can now have the actual number of people that are in the class. So if we do that, we call that P union C. P stand for physics and C stand for chemistry. So if you subtract 31 from 5, we have 26. Now from here, we're going to continue our calculation. Now we said that the number of people that study both subjects should be what? Should be X. So if you want to know the exact number of people that study physics, since there are some people that study both subjects, then we have to subtract the number of students that study physics from X. The same thing applies to chemistry. Number of people that study chemistry from X, which is 22 minus S and 20 minus S. So in the short while, I'm going to be showing you how we can actually get the diagram, which is the Venn diagram. On the next page, we are going to be calculating the number of X together and fix it into number of physics students, number of chemistry students, to know the exact student that study physics and chemistry and the exact number of students that study both subjects. So let's check what we have here. So this is the Venn diagram. Let's quickly draw it. What this one is telling us is that X is common to both of them, because there are some set of students that actually study physics and chemistry together. So that is why we are having P intersection C to be X. So let's quickly calculate together. So we are going to be calculating this together. Okay, to have the number of students that study both courses, we have to add all the students that study chemistry with number of students that study physics with number of students that study the both courses. Then that is how we can actually get the number of exact students that study both courses. So for physics here, the number of students that study physics is what? The number of students that study physics is 22. So 22 minus X is going to be 22 minus X plus 20 minus X, then equals 26. How did you get 26? That's the total number of students that study both physics and chemistry. Okay, so we have 22 minus X plus 20 minus X plus S equals 26. So let's add 22 plus 20. We are collecting like times here. That is 42. Now X minus X, that's 2X plus X equals 26. Minus 2S rather plus S, that will give us minus S. So we have 42 minus S equals 26. How do you get minus X? You have 2 there to give 1 out of it, and you have a debt back. So that's just the concept between a negative value and a positive value. So now we collect the like times by bringing 42 to the other side. We have X equals to, remember I've told us that the sign must change. So this changes towards minus 42. By the time this changes to minus 42, so it's going to be minus S equals minus 16. We can't leave it this way because we actually need X, number of students that study both subjects, and not a negative value. So this, we cancel this. Our S is now going to be 16. So having that, now let's check the number of physics students, which is going to be 22 minus X. What is 22 minus X? Now, what is X? X has been calculated to be what? To be 16. So we have 22 minus 16. That is what? 6. So the number of students that actually studies physics is 6. Now for chemistry, it's going to be 20 minus X. What is X? X is 16. So we have 20 minus X. And that is what? 4. So 4 students studies chemistry, 6 studies physics, while 16 actually studied the 2 of them together. So this gives us the solution to the question we have here. Look at this past question. We are going to be explaining in details, and the next slide is going to be giving us solution. Let's study this Venn diagram. This is L. Set L consists of all of this, while set C consists of J, Naira, Bella, Vi, and Ada. Now we have to complete this statement. N, this is what universal set. They are telling us that how many elements or members are actually inside this Venn diagram. This is the meaning of what we have here, because universal set means what? All the elements in a given problem. So let's count how many elements we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So for this place we have 12. So our 12 is going to give us the final answer. So the number of elements in that Venn diagram is 12, and that gives the answer for the first one. The second one says, work out the fractions of the customers who like lemon cake or chocolates but not both of them. So now let's look at it. Since we have 12 for all the elements in this Venn diagram, let's look at how many people, students, or how many customers rather, like lemon cake. So let's count those that actually love lemon cake. This is 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. Since we are working with a fraction, 8 is going to be the numerator, which is the number of people that actually like cake, while the denominator is going to be the total numbers of customers. So for lemon cake is going to be what? 8 over 12. While for the chocolate cake, let's count. 1, 2, 3, 4, 5. So for chocolate cake is going to be 5 over 12. So by the time you add both of them together, 8 plus 5, that's what? 8 plus 5 will give us 13. So we have 13 over 12. So if we have that, then 13 over 12, then we can change the proper fraction and we have our answer. Now let's look at the next one. Use a set notation to complete this statement. So if we are to write this, it's going to be what? L intersection C. Why? These are the two people that actually love to take lemon cake and chocolate cake at the same time. So we denote that with the use of a set notation as what? N intersection C. And what does Venn diagram shows about Taj? So this one is telling us that Taj does not actually like any of these variety of cake. So Taj is actually sitting on a fence. So the next slide is actually showing us the solutions to what I've explained earlier, and this is taking us to the end of the class. Thanks for listening. We want you to subscribe to our channel for full interactive content of this topic. Our channel is www.edubbey.com. Thank you.